This video is in response to a comment that was posted last week by someone called Kev, and he said, imagine if we had to differentiate sine 2x from first principles. Well, let's not imagine, let's get into it, and we'll differentiate sine 2x from first principles. Now, the first thing to do is obviously to set up the initial equation here. We've got y equals 2x, and we know that dy by dx is going to be equal to the limit as delta x tends to 0 of the following. So we've got sine 2. Now wherever we see an x, we replace it with x plus delta x. We subtract the original function here, so sine 2x, and that's all over delta x. So we have the limit as delta x tends to 0 of. Now what I'm going to do here is I'm going to expand these brackets. So that times that and that times that. And what we get is sine of 2x plus 2 delta x minus sine of 2x. That's all over delta x. And just put that bracket in there. Now this is where the trick comes in on this one. If you look at the sine of 2x plus 2 delta x minus the sine of 2x, what you might notice is that this is one of the trig formulas. So I'm going to write that down just as a little reminder for you. So if we have sine A minus sine B, so that's what we've got here. We have a sine A, let's treat this as A, and sine B, let's treat this as B. Now, if we have that, we can write it as follows. It's 2 cos A plus B over 2 sine of A minus B over 2. Okay, so using that, we can rearrange this equation here as follows. We've still got the limit as delta x tends to 0. Okay, so now we've got A is this part here, the 2x plus 2 delta x, and my B part is the 2x. So let's substitute those in. We would have 2 cos A plus B, well, that's going to be 2x plus 2 delta x plus 2x, that's all over 2. And then we've got sine of A minus B, so that's going to be 2x plus 2 delta x minus 2x, that's all over 2. And the whole thing is over delta x. I'll just put that bracket in on the end. We can now start to simplify this a little bit. We've still got the limit as delta x tends to 0 of the following. We've got the 2 cosine, here we go. Now let's go ahead and simplify this bracket a bit. We've got 2's everywhere, so we can cancel the 2's. So that 2 will cancel with that one, and that one. And what we'll be left with is 2x plus delta x. And then we've got the sine. And then we've got here, we've also got a factor of 2 we can deal with. Well, the 2x and the negative 2x, they'll just cancel. And these 2's here will cancel, just leaving me with the delta x. That's still all over delta x, bracket on the end. Now looking at this limit here, this delta x tending to 0. And I'm going to deal with sine of delta x over delta x. Now what I know is that as delta x tends to 0, sine delta x over delta x actually tends to 1. And you can do a little bit of investigation if you wish, if you grab a calculator and just put in a very, very small value for delta x. So sine of 0.0001, and then divide that by 0001. You'll actually find that actually tends to a value of 1. So what we have then is that, well, if this here tends to 1. And obviously this delta x here is going to tend to 0. What we're left with is just 2 cos 2x. So there we go, Kev. As you can see, it is possible to differentiate sine 2x from first principles. Now, I know it's a little bit more complicated than most questions, but it is still possible. Now, if you found this video useful, remember to give a quick thumbs up. And if you'd like to be notified about all future videos, then just subscribe and hit that little bell notification icon.